Okay, I'm going to walk through the 3 different forms of a quadratic equation. When we were solving for quadratic equations, we knew that we could solve them in multiple forms. We could solve, remember, we could solve it by factoring. We could solve it by completing the square. And we could also solve by the quadratic formula. Okay. And each one of those took the same information and put it in different forms so that we could get an answer. So just like we can solve using different ways, we can rearrange our equation in different ways, and it gives us a little bit more information of the puzzle. It's just like a puzzle and you're just looking at it different ways. Or say it's like taking a picture of your house. You're taking a picture of it from the front side, then from the side, and then from the back. It's the same house. We're just looking at it with different angles, and it gives us a slightly bigger picture. I'm also going to try to walk through a couple of linear equations and how they look and why it still looks the same with it, okay? So when we initially have everything equal to y, this is our standard form, okay? This, if we were comparing it to a linear equation, so I'm going to write linear over here, would be y equals x plus b, mx plus b, okay? So when it's solved for y, this is our standard equation. It tells us, just like a linear equation tells us, this is our y-intercept, okay? In the same way, we have a y-intercept here, okay? The reason that works is a y-intercept simply means where does my graph cross the y-axis? And if a graph, no matter where it's at, crosses the y-axis, then the x is going to have to be 0. So when my x is 0, it removes every part of the x. So that erases out of the equation, and we simply are left with when x is 0, so here's our point, when x is 0, then the only thing that's left is y is -6. So just like a linear equation, our b gives us our y-intercept on a quadratic equation in standard form. Our b gives us our y-intercept. Same thing, okay? So if we have a quadratic and we can solve it, let's use this one here. And we can go ahead and factor it. Remember, factoring was one of the ways that we could get an answer. In this case, we can factor a 6 into a +3, so x plus 3, x minus 2. We can factor this quadratic into our 2 polynomials here, okay? So when we set y equal to 0, this was back with quadratic equations. When we set y equal to 0, so what is that giving us here? If y, remember these are our x values, these are our y values. When y is equal to 0, we were able to set each section equal to 0. So when y equals 0, I have x plus 3 equals 0. So x plus 3 equals 0, so x equals -3. So there's one option. When x minus 2 equals 0, x equals 2, here is our second value. These values have a specific name. In our equations, these are called the solutions, right? So when we are solving a quadratic equations, we typically just get the answer of -3 and 2. That is the solution to the equation. So the solution here are actually our x-intercepts. So in this lesson here where we are learning about quadratics, a solution is always equal to your x-intercept. Okay? So now we have an x-intercept of -3, 0. We also have one of 2, 0. Okay, now what can we deduce from this? Well, we know, as we talked about the shape of a parabola, that is it is equal on one side as it is on the other, and that your axis of symmetry runs right down the middle. Well, I have 2 on this side and 3 on this side. So I have 1, 2, 3, 4, 5 squares. The middle of 5 is 2.5. So my axis of symmetry, I already know, is going to run at -1/2. Okay, that's the only way that I can get right between those 2 points. Okay, so I'm already looking at my vertex. I know my vertex has to be on my axis of symmetry. So I know my vertex should end up being a -1/2 for my x value. So that's some information that I've gotten already. Okay. So in the same way, if I had a linear equation where I have, and they give me a point that solves it. So we're going to use point slope form. Example for this one. So I know that the point 1,7 solves my equation. I'm going to do a slope of 1. Okay. So my m here is my slope. It tells me the direction, just like our a value here tells us the curvature. Okay. And I have some different values for points that I know that solve it. We can go ahead and rearrange this into what's called our vertex form. To have our vertex form in the same way, we want to have y and any extra numbers over on the left side, and we want to have our curvature. So in this case, it's slope with a quadratic. It's going to be your curvature. Okay, and then any x values combined. So we have y's over here and we have x's over here. Okay, so let's go back to our y equals x squared plus x minus 6. Okay, I want only x values on this side, so I'm going to move my 6 over. So I have y plus 6 equals x squared plus x. Well, in this case, I know my curvature, but I can't just leave this because I actually need a number. So how can I get a number here? Well, this is how we use completing the square. Okay, so to complete the square, we take our b value, we multiply it times half. So in this case, I have 1 times 1/2, and then I'm going to square it here, okay? So 1/2 squared is 1/4. Now, the cardinal rule of math is whatever I do on one side, I also have to do the other side. So I'm going to add 1/4 on this side. Now I have y plus, and we'll just do it this way, 6 1/4 equals, now how can I rewrite this where I just have an x value and a number? So this I can do the square root of x, and then the square root of 1/4 is 1/2. That's why we needed this number right here. They're both added, and it's this whole polynomial squared. So x plus 1/2 all squared. If I FOILed this out, I would get x squared plus x plus 1/4. Okay? So I'm simply just rewriting what I already had. Now that it is in this form, this is called your vertex form. You will often see it written like this. Okay, where you're still solved for y. Okay, so whenever it's still solved for y, you still have, just like up with your standard, this tells you, your number at the end tells you how you're moving your graph up and down. Any numbers associated with x tell you how you're moving your graph left to right along the x-axis, okay? Because there can be confusion with the signs, I personally like to leave it, for example, I would leave it like this. Okay, so when it is in vertex form, if my x is 0, okay, I have my value over here. So this is my y value that I'm changing my my graph equation by, and this is the x value that I'm changing it for. So if I was to set this side equal to 0, I have y equals negative 25/4. So we would have the opposite there. And x, if we set that little section to 0, x equals negative 1/2. So my vertex is at negative 1/2, negative 6 1/4. Okay? So when I worked out my equation, my guesstimate was that it was negative 1/2 because that's the only way I could get in the middle of my two solutions. When we solved it, we got negative 1/2 for our vertex. So we were correct in that. So our vertex is down here at negative 1/2. I can also justify that this is the right answer because my y equals x squared plus x minus 6 original equation, my a value here is a 1. It is positive. So my graph is going to open up. Because my graph is opening up and it has to go through these 2 points, my vertex has to be below them. Okay? So we would do 1, 2, 3, 4, 5, 6 1/4, and that would be our vertex. And we could sketch our graph along our line this way. Remember, we also have the shortcut coming from our graph that our vertex, the x value of our vertex is always negative b over 2a. So in our original equation here, negative b is negative 1 over 2 times 1. Because a is 1. So our x value is negative 1/2. Again, we got 1/2 when we were splitting the difference of our solutions. We got 1/2 with our little cheat sheet formula. We also got 1/2 when we transitioned our equations. So we have standard, we have our factored form here, and we have our vertex form here. So same equation the whole time, same equation. We are just rewriting it, just like when we had a linear equation and we could move the numbers around. So we didn't add anything, we didn't change anything. We simply took our standard equation, we wrote it in a factored form to give us one view of the graph. We rewrote it in our vertex form to give us some more answers for it. And that's how all three of those forms work together.